Hey everybody, this is Larry. This is me going over Q3 of the Leetcode bi-weekly contest 68. Check if a parentheses string can be routed. So this one was, for me, the hardest problem of this set. So you can, if you're one of those people who leave comments on my YouTube videos saying that you love watching Larry struggle, well, there's enough of that, so you feel free to watch that in the live portion of this video. It's a contest video, so I will, you could see me try to do it live, even though it was a virtual contest. So to be honest, I tried a number of greedy solutions for this one, and I don't know if there is a better solution, but feel free to hit the like button, hit the subscribe button, join me in Discord, and maybe we can actually review some. I'm curious whether there's a better solution. But I tried a lot of greedy solution. I try to treat the unlocked ones as wild cards or something like that, and then I did some greedy thing of, okay, if there's this logic, if there's this logic, if there's this logic, you do this thing, right? So I definitely try a lot of that, and all of them as well. I actually end up spending about 27 minutes on this problem, which is roughly the longest, especially if you consider the two incorrect attempts, both of which were greedy solutions. I'm not going to go over that much, just because I was like, oh, maybe this is right. And then I found a case in which I was like, okay, this is clearly not right. I had to figure out how to do it. But eventually I did land on one key fact, which is so the reason why we're greedy is that because it just feels so natural to use a stack solution, and my solution did ultimately use stack, but not directly. But the key fact that I kind of took a long time, to be honest, to come up with is just figuring out how. Well, one is there's a fixed amount of quote-unquote wildcards, right? I'm gonna call these wildcards. I just meant that they're unlock strings, so you can make them anything. It doesn't really matter, right? So once you have that, there is a greedy concept, though not algorithm, of that. Okay, if you're gonna add left parents, you should always add them to the left, and when you add right parents, you should always add them to the right, almost like in a greedy way, right? Because at the very end, you have extra left parents, and in the beginning, if you have too much right parents, you just get it out. And in the middle, if you kind of hold up this structure, at first in the middle you just have a higher mountain, if you will. Like you can maybe do a little, a mountain of stack size, right? So that's basically the idea. Once I did that idea, I did a binary search, because now you can test, because there is a I don't know if I would call it monotonicity, but there's a property, right, in which, okay, if you have too many left parents, what happened? If you have too many left parents, then you would have left parents left over. If you have too few left parents, you have too many right parents, and therefore you terminate early. So there's only, if there's a routed answer, there's exactly one balanced of left parents and right parents, and they meet somewhere in the middle depending on how the locked pieces work, right? So that's basically the idea, and then we'll go over it now. Though the binary search implementation is a little bit awkward, and this is where if you have a strong binary search ability, that's where you can kind of make these small adjustments to kind of make sure you get the right answer. And we'll go over it now. So basically, this is the go function that I have with a terrible name. But what this does is, okay, given the first X wildcards are left parents and the rest are right parents, will we have left parents left over? The reason why I structured this question this way, particularly this particular part where we have left parents left over, is because so that we now convert it in a thing. Because if you just say, can this be true, it's just going to be false, 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 true, false, 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 right? Because it's only going to be true for one place. But if I rephrase this as, will we have left parents left over, then if we do have left parents left over, then we know that we can remove some. So this kind of gives us that 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 idea, right? And I also added an extra thing to just even though that's the basic question, I added an extra thing just so that I don't have to kind of run another loop at the end. And that's basically the idea. So this is standard binary search stuff. Basically, you know, the left and the right maybe is a little bit confusing because we're used to it in other ways, but this is binary search where the lower bound is 0, where the upper bound is the number of wildcards, right? Because all of them could be left parens. And then here, this is standard binary search stuff. I do this, I call this binary search function. And basically, if this is true, well, this is if result is true, that means that we have an answer where the length of the stack is 0, right? So this is, if we found an answer, then it is true. Otherwise, we have too many left parens. Let's use fewer. So that's basically why we have, when we reduce the size of the right of the size of the binary search, we make it smaller. Also because we have too many, because we have too many left parens, mid cannot be the answer. In fact, technically, I think you could also have done this because we know that mid is not the answer, because if it is, then this would have already returned true. But I just did it from, like the way that I always do it. That's basically why. But basically now we have we have too few left parens. Let's use more. By setting left is equal to mid, we use more because then now your bound looks like this. Now you go to the right. And then at the very end, if for some reason this doesn't trigger, we do it one last time. Basically when left is equal to right, we have quote unquote the least amount of parens that we're going to get, left parens that we're going to get, and then we just do this. That's pretty much it. So in terms of complexity, this function is going to be linear time. I mean, this is a very basic linear time function-y thing. And here we are going to make O of log n at most iterations. So in total, this is going to be O of n log n time and O of n space because of all the stack that we keep on using, though of course we free it afterwards maybe. But yeah, let me just scroll up real quick. Oh, and the other thing that I missed is that of course, if the input string there's an odd number of characters, that's just not possible, right? So we make it forced by default just to save some time. But yeah, let me see. So we have this part and this part. So the next question I want to answer is whether this could be an interview question. I think this is a good question. I think this is a little bit too hard for an interview question, but I really dig this problem, to be honest. It's very interesting. It's very cute. Like if you think you're like it's a non-standard problem, maybe, or like it wasn't standard to me anyway. And everything that I described to you, everyone has the capability of doing it beyond like the beginners, right? Like binary search and a stack. That's all I needed. So nothing like advanced or complicated or complex. But yeah, but that said, this is not easy. It takes a lot of creativity. So yeah, let me know what you think. And you can also watch me solve this live next. Be sure you hit the like button, hit the subscribe button, join me in Discord, all that stuff. Did this during the virtual contest because I went hiking today. But you can see like how I struggled and even the what kind of greedy solutions I was trying to make and what kind of mistakes I was making. So check that out. Let me know what you think, and I'll see you in a little bit. Or this is a test contest. I don't know if I would have submit during the contest, to be honest, because that was a little bit on the edge, if you ask me. But let's see. Let's see. Paren strings can be routed. Let's do Q3. A B. Given a parenthesis string S and locked. This seems pretty straightforward, maybe. Is the length always odd? I mean, always even? Okay, no. So, yeah, I think, okay. So, oops. If length of s mod 2 is equal to 1, then we return false. Locked, right? Okay. Locked is the same length. Okay, so then now let me think about this. I guess my question is, do you greedily remove stuff as it is possible? So does it make sense to make them all left parents? And then as we see them, can we ignore left parents? I'm trying to think whether is there any way we can be greedy about it in a good, consistent way. Let's see. This is a variation I don't know that I'm familiar with, but maybe we can look ahead. I feel like we still use a stack pretty much, but we just kind of see how many things are there. We just have a wildcard on the stack maybe, and then we'll try to match as best as we can. Okay, yeah, let's try that. For P L in SIP of S locked. Okay, and then if lock is equal to 1, then we have to do stuff. If lock is equal to 0, then we put in another stuff. I know I just said nothing. Okay. So lock is 0, then let's see. If length of stack is equal to 0, stack dot append, I don't know, I just go store for wildcard, else we just pop it because we just match one of the other ones. Okay, now if lock is true, if length of stack is equal to, or is greater than 0 and stack of -1 is equal to, well, let's actually rewrite this a little bit. If length of stack is equal to 0, then what happens? The two cases, right? One is if p is equal to 2, then we return false. Otherwise, if p is 2, then we, which is the only other possibility, we append the left thing and then continue. Else, so then now the stack is not 0. If stack, the top of the stack is equal to star, then we just ignore, right? Oh, we have the pop, and then we ignore the current character. We just consider that as matching, and then continue. Just to be sure, I guess we don't really need it, but else if okay, and then if p is equal to let's see, left parent. I think just breaking down the cases. If this is equal to left parent, then you just always append it anyway, right? Like there's no point of not, or like that's just how that works. And then now, if it's to close that thing, then you have to do if stack. Oh, this is actually a lie then, right? Because that doesn't really make sense. So then if P is equal to this, we always append. Yep. And then else, if it's equal to star or left paren, we get to pop it because this is now a right paren. Continue. Else, this is just return false because now it's not. Because, well, it doesn't make sense. Well, this cannot be. Well, I guess this cannot be true because there's no, you're never appending a right parent or anything else. So, okay. And then now we return with length of stack is equal to 0. That means that everything is good. So I think we're good here now. True false. Let's give it a spin. Oh no, I got a wrong answer, huh? I was a little bit confident about it. Maybe I should have tested a little bit, but let's see. Oh, I returned false, but let's see. That's interesting. So basically here, oh, I see what could happen. What could happen is that I match this, but the right parents need this to not match this. So my greedy was a little bit off here. Where's my star case? So if it's unlocked, we don't, then how do we do it then? Because this always match left paren, but we don't always want it to, right? I guess we can always just append this and then yeah, and then at the very end, we just kind of do I guess I could have just counted the left parents, but fine, let's do that. Okay, I printed too much though. Where's my print? What was the answer again? The answer is expected is true, false. Okay, I think we're good now. Wrong answer again, huh? Wow, I really don't know how to do this. I thought I did a little bit. Let's see. Glad that I did not do this one then. Expected true, but I returned false. The only way I return false is here. Right? Oh, well, and or here, I guess. Let's see which one it is. That's an odd thing to be left, though. Oh, I know it's not, I guess. What does this mean? Well, friends, really glad I did not do this contest, especially in my limited capacity. Okay, so print a little bit more because I have no idea what I'm looking at. Okay, so oh, huh, I'm just being silly. I had this if statement left in there, but I meant to take it out after I took out the other thing. But yeah. Still wrong though, so that's not the only thing. That is a thing though, but that was definitely a bug. But that is a very awkward bug. Okay, so I have all these things. Let's see. I just wonder, I guess the other thing that I could have checked is whether they match. But I don't know if that's trueable. Because there's some like crisscrossing thing that I'm not sure if. No, I think that should be okay. It's still false though, so that's not it. I guess the wildcards can be anything, so we would use it to match if we want. But is that even true though? Because in this case, the last character could be a left parent, and this would be false. So now I'm actually thinking about a problem. Before I thought I just had intuition, but sometimes intuition is wrong. So yeah. So how do I think about this? Well, for this quote unquote stack, we want to make sure that for okay. Yeah, I think I was messing something up because if the last one was and left open paren, it wouldn't work anyway. So okay. What is the easiest way to do this? Basically, we just do this and then we match these other things, and that should be okay. Okay. Wow, what a sloppy problem for me. It's one that I didn't have intuitive for, I guess. But yeah. What is an easy way to implement this? Because basically, if I do something greedy, like I just want to, okay, fine. I guess just whatever. Wow, I'm really bad. Okay, let's just say left. Is equal to the 3 is equal to the okay, for I x in stack. If x is equal to the left outer band I, else free outer band I, and then now we just match. Yeah, okay. Okay, while length of left is greater than 2, and if left of 0 is before 3 of 0, then this is easy. Left dot pop left, 3 dot pop left, right? There's a bug on my screen. Annoying. Okay. Okay, so while length of 3 is greater than 0 and f of 0 is greater than 3 of 0, and we just return length of left is equal to 0. Maybe? One time error, what? Oh. So I guess I don't need that extra if statement, but still false, huh? Why is that false? Tell me why. Do. stack of this. How is that? So 0, 1, 7 definitely matches something. 10 matches something. 23. Oh, wait. There is a left thing on the stack. Why is this expected to be... So I have this thing. Right, and this is a star. But the left paren, or the right paren. Did I mess something up? I guess I'm really wrong on this one. Wow. Okay, on the right paren, we greedily pop. And that's apparently not the idea. Well, I mean, there's nothing... No, this has to be a right paren. So why do I have a left thingy here? Left thingy, this one matches with... Oh, because this one matches with this one. But we do need this one to be a right thingy. But the right thing pops off this other thing. Okay, that makes sense as to why this is wrong. Unfortunately, now I have to think about how to fix it. My greedy thing really does not handle this case. Maybe I was just thinking about it too much on greedy. Let's restart. I thought we could greedily do some stuff, but this is a case where greedy is wrong. Because this took away the wild card. And it's 10 to the 5th, so there's no really fun. I think stack is still the way to go, but clearly my recurrence is very wrong. Let's at least keep some components of this. This thing maybe is not so good. Let's see. The length of... I mean, this is true. How do we make this wildcard? How do we force this wildcard later to match the left one? Not gonna lie, I'm struggling a bit with this one. That is the case. I'm just trying to simplify this a little bit. In theory, this should be true. Oh, whoops. And it might still be true. I don't know if the running up for it. Well, I guess I took out a lot of the code. But what I really want is just printing the stack. Yeah, so this gives me this, which is not joy. Maybe I need to make one more observation. Pushing the wildcard doesn't do enough. I mean, Yeah, I guess we could pre-process the number of wildcards in the future and then kind of match that way. Feels weird. I mean, I think this case is the one that I don't know how to deal with right now. At least in a consistent way. Like, if we treat this as something that we can stack off, then what? Well, okay. I guess I have a binary search answer of... Is that even true? Of basically how many... So I guess the idea... Okay, now I'm thinking is that of all the wildcards, X of these have to be left and Y, and then the other half is going to have to be the other one. So then now you binary search to see which way to go. Okay, maybe that's I don't know if that's the answer, but let's see if I can do it. Def go. Let's just say X. Okay, and we have a stack. Okay. Let's see if lock is equal to 0. Okay, then this is 3, and if it is the first, if X is greater than 0, then we make this a left, else make this a right, and then we just decrement, and then beyond that, this just becomes straightforward. Yeah. If P otherwise, if P yeah, and you can actually mod this with a number now, but I'm just going to keep doing it this way. Dot pop. Okay, and then now left the number 3, which this is fine. Oh, and then now what do we want to return as a number? Okay, so this is too few. So in theory, this is true in that we'll have extra, and then we just have to run it again, maybe. So I have save later. Right is equal to the number of unlocked. So let's see. Right is equal to 0 for. Right is equal to lock dot count of 0. Okay, and then now we do a binary search stuff. So we're going to go with the mid. this is inclusive, okay. If rest up one, then we return true, because that means that something worked. Otherwise, if the result, that means that we have too many left parents, so we want, and it's good, so we want to try doing the right parents. So that means that we want fewer. So right is equal to mid. Don't know about the conditions, because if we want this, if we need more left parents, and the tiebreaker goes to, so okay, fine. I think this is right, but I'm not sure. Okay. Go left. Something like this, maybe. Don't know if this is right. Okay. Oops. I guess this could be a walrus thing, but okay, true, true, false, true, true. Is that right? Is this true? I don't even know. I know this one is true and this one's true. I guess this one is true too. Let's give it submit. Can I see where that goes? Okay, that's a cute problem, actually, to be honest. Hey everybody, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about these problems. How did you have fun, or whatever. That's all I have. Stay good, stay healthy, do good mental health. I'll see you later. Bye bye.